Hi everyone, welcome back to Coding with Bharat channel. So let's take up the fourth problem of the weekly 388 contest, right? Which was kind of like an ambiguous and hard problem. So yeah, let's get directly into it. So the question says that we will be given an array of size n and we'll also be given a positive integer k. So an array and an integer k. Now what we need to do is we need to select k disjoint subarrays from this number, right? So k disjoint subarray. What is disjoint? Disjoint means that the subarrays that we select, they should not have a common element, and you want to select k such disjoint subarrays, and you want to maximize the strength of this selection. So what is the strength of a selection? So the subarrays that you select, you first need to calculate sum of each of them, right? So for example, sum of 1 represents sum of the first such subarray. Sum of 2 represents sum of the second such subarray, and so on and so forth. One thing that which was unclear here in the question is that we are actually taking the subarrays in order of the way we start the selection from the beginning. So for example, if the original array is 2, 3, 4, 5, 6, and you take the arrays as 2, 3, 4, 5, and let's say 6, three arrays. So they have to be taken in order. You cannot do such a thing that, okay, the last one becomes your first sum of 1. The second one becomes your, let's say, sum of 3. That kind of changes you cannot make. So whatever you take first has to be taken first. Then whatever you take becomes the second. Then whatever you take becomes the third. So order was fixed, right? That was actually missing in this problem. And that is why I think it had lot less submissions than what would have been possible. So yeah. But yeah, that is there in the question, right? So we have to select them in order. Okay, so you want to select k such disjoint subarrays such that when you take sum of each of them and apply this formula. What is the formula? First subarray that you select into x, sum into x. Second subarray that you select, that sum into x minus 1, but with a minus sign. Third subarray that you select, sum into x minus 2 with a plus sign. So on and so forth. This is the entire thing known as strength of a selection of subarrays, and you want to maximize this strength. Okay, so a complicated question altogether, right? But so just to delve it into a very simple fashion, you have to divide it into subarrays. First subarray sum into x, second subarray sum into x minus 1, third into x minus 2, so on and so forth, plus minus, and finally you get the result. Okay, now let's get into how we can solve this particular problem. So let's go to this board. Okay, first thing that comes to the mind when we are dealing with such a problem is to go greedy, right? So what greedy could be done here? So what we could think is that, okay, the first subarray that we select has to have positive numbers because we are multiplying. The next has to have negative numbers. The next has to have positive numbers, so on and so forth. But that fails due to a lot of reasons. First one, and the simplest one, being that even when you take k is equal to 1, you are taking just one subarray, right? You would think that let me take the positive numbers only, right? But if you take the smaller negative number in the middle, right? Let's say if this was just a small number, minus 2. So actually what you would see is you will get a better answer. So 3 plus 1 plus 2, 6. If you would have taken just this, then 3. If you would have just taken this, then 5, right? So yeah, better to take this negative as well and take the entire thing. So, and this is a common reason why your standard maximum sum subarray problem, which is solved by Cadane's algorithm, that also fails with greedy. Why does cadence fails with greedy? Because in cadence you try to do a very similar thing, that okay, taking a negative number in the middle might combine two huge positive numbers to get a better sum. Okay, so with that in idea, because cadence also uses TP, and when we think about choices, so this problem also had to be solved with a similar idea with choices. So let's get into it. Okay, let's say I have to select 3 subarrays and I have some array like this. Okay, initially let's think about what choices do I have. One choice is to ignore this element altogether, right, and say all your k subarrays should be on the right side. Another choice that I have, I start a subarray from this point. So two options, either to ignore it or start a subarray from 2. Okay. Now let's take the case of ignoring. If I decide to ignore this 2, then for 1 also I have the same choices. Either ignore 1 also or start a subarray at 1. Right? Remember, when we are dealing with DPs, we generally do not, like, we can combine it with some optimization for greedy, etc. But generally we first think about exploring all the opportunities or all the possibilities. So that is exactly what we are doing here. Although it would not make sense to ignore this one, right? For a huge number like k. But all those things we are not getting into it. When we are dealing with recursion and DP, we don't think of optimization, we just write brute force, right? Think of all the choices and just list down all the choices, right? Okay. So yeah, 2 we had choices, ignore it or take it and then start a subarray. Again, 1 we had a choice, ignore it or take it and start a subarray. When we reach from this starting at 2 a subarray, when we reach this one, then the choices are either to include it in the subarray and keep going. So either include it to 1 and continue, or what I can do is not include this 1 into the subarray and stop my subarray at the past. So I'll say that okay, your subarray closes at 2 and now I have a new element at this 1, right? And I'll try to again ignore it or take it and move forward from there. So I'll say close the previous array and still stay at 1. You decide for 1 what you do, right? You do one more choice with this one. Why? Because again, you can start a new subarray at this one, or you can decide to not start a new subarray at this one, right? Cool. Let's move on. So yeah, basically this is what we had to in totality do in our problem as well. So you have two options. If I try to summarize it at any place at index number I, if a subarray is continuing till this point, right? So if in the past subarray has been continuing till this point and we have reached this I, either we can include it in my subarray, include it in the subarray and make a call for I plus 1, or close my subarray till I minus 1. Say that okay, I don't want to include this into my previous subarray. You close your subarray till that point and I'll make a new decision for this I, saying that no new subarray has been starting yet. If you reach this I with no new subarray, like no subarray has been starting till this point, then again you have two options. Either you can start a new subarray here, so you'll make a call for I plus 1 saying that I have started a subarray at the previous point, or what you can do is you can make a call for I plus 1 ignoring this I. So say that go to I plus 1 ignoring this I. Okay, so that is how you can make your 4 calls. So if we had an array continued from the past, we have two choices, If we don't have an array continuing from the past, we again have two choices: to start a new array here or to ignore this and move on. So basically, if you think about it, you need three parameters here in your recursion, which is your index, the index that you are currently on, then a variable whether started or not. Like, are we reaching here with a previous array continuing, or are we reaching here with a previous array being ended in the past? So I'll probably call it ended. So this is 1 if the previous all subarrays have been ended in the past and we have reached here. If this is 0 means the past subarray has not been ended. It's like true or false. The past subarray has not been ended and we are continuing from this point. Third thing is k. How many more subarrays we want to create in the future, right? So this could be your way. Okay, so if ended is 1, that means a new subarray can start here, or an old subarray can or we can ignore it. So what we'll do, we'll make a call for index plus 1 with 0 if we are starting a new array at this position, and k minus 1, saying that okay, we have started a new array, so now we need to create one less in the future. Or I'll make a call for index plus 1 having 1 and k, saying that I'm ignoring this element. When I reach a particular position with 0, then I have two options. If ended is 0, that means I can either continue this and put this into my subarray. So then what I'll do is I'll make a call for index plus 1 with the same ended and with the same k. Or what I can do is I can decide to not be a part of the previous subarray, right? Close it in the past, and then again make a call for this to decide for the 1 case. So I'll say I'll make a call for the same index with 1 and k. So ideally this would actually go into this left call and again make two choices from there. Either you ignore it or then you start a new subarray at this point, right? Very important to not go plus 1 here, because then in a way you are saying that this element is ignored. You are closing it in the past, right? You have closed it in the past, you have not included in the previous subarray, and you have moved on. So then what will happen? This index is automatically ignored, but that you cannot afford. You might have started a new subarray at this point, right? So that case needs to be considered. So that is why this has to stay at index and not index plus 1. Okay, so let's see this recursion in action, and then how did we memoize it. So memoization part is easy because we have three, you can say, states of ours: the index, the number of elements, number of subarrays, and ended or not. So we can actually make a 3D array of size n, 2 because it's just 0 or 1, and k, right? N into k was within our range, so n into 2 into k would suffice. Let's go into the submissions and see the code for this. So what I've done, I've created this 3D array, dp 3D array of size n. I've taken plus 1 just to be safe, 3, again I've taken this plus 1 to be safe, and k plus 1. So n into 2 into k is what I wanted to achieve, and I've put the values as long max. Yeah, so this I've put as so values that have long max, that means that they are not yet calculated, like those states have not yet been calculated, right? So we'll see how this dp comes into the action, but before that let's focus on the recursion solely and see how recursion is happening, right? So I've called this recursion with three values, 0, 1 and k. So 0 position that I'm at, 1 has ended because all the past ones have ended, like none of this subarray has been continuing so far, right? And k, what is k? K is what I need to create with the entire array, right? So these three things. So you'll also see that okay, I have position, I have ended, and I have x. Position ended x. Apart from that, it's just nums and dp. So dp you can just let go as of now, but nums is your number array and it is not changing. So it is not part of the state. Okay. Let's go into the two cases, if ended and if not ended. There are two cases. If ended is 1, if ended is 1, that means either you can start a new thing here or you can ignore it, right? So first thing that I've done, ignored it. So I made a recursive call with position plus 1 ended x. So just move on to the next position, keeping all the other variables as same, right? And the value that I have got from there, the result that I've got from ignoring, that I've put in a. So if x is 0, what is x0? x0 means we don't want to create more arrays. The more arrays that we wanted to create are 0. That means I cannot start a new array. So I'll simply return a. Forget about this dp for now. Just focus on recursion. If ended, that means all the previous ones have ended. You ignore it. If you cannot create a new array, that is your only possible answer, to ignore it. So you just return a. Whatever you get back from ignoring. Second case is when you can start a new array here and you start. So I'll make a recursive call with 1 minus ended, because now 1 minus ended means 0. That means we have started a previous array, right? To position plus 1 and x minus 1. Why x minus 1? Because we have started a new array, so we don't want to create more in the future. Okay. So when you have started a new array here, that means this is part of your xth array. So you want to multiply it with x and add it to your answer. So that is what I've done here. So whatever b you get, if it's long min, that means when do I return long min? When it was not even possible to get a solution out of that range. So if it's long min, then again we don't have an option. We'll return a. We cannot calculate for this b because this b is returning long min. Otherwise, for this b you add up. What do you add up? You add up nums of position into x. Nums of position into x. But that nums of position into x either would be plus or minus depending upon the parity of my x. So if x minus 1 is odd, then you'll add it as negative, otherwise you'll add it as positive, right? So this you can calculate, like x is always, like k is always odd, so it will go like odd, even, right? So yeah, based on that we are either adding or subtracting. Cool. So if both a and b we have got by ignoring or by starting a new array, then I'll put maximum of a and b, like maximum of the two cases, the answer, and return it. Second case is when we arrive at this ith position with a subarray being continued from the past. So either you will close it or you will continue with it. So first case is when I decide I want to close it. So I don't want to include this in the previous subarray and close it in the past. So I made a call for same position. Make a call for same position with different ended, like make it 1 and make a call with the same x. Second option is when you want to include it in the previous subarray. When you want to include it in the previous subarray, then you just make a call for position plus 1 with the same values. So position plus 1 with the same values. And not only that, but in this then you are including this into the previous subarray and you want to add value for it. So you'll do b plus equal to, again, nums position into x plus 1. Right? Why x plus 1? Because the previous one is being continued. X tells you how many you want to create in the future. So this was in fact your plus 1th array of it. Right? So that is why this is x plus 1. Again, if b returns long min, then you don't have a choice to continue. You have to stop and return whatever a is. Otherwise, you again take maximum of a and b and return it. So yeah, idea is the same as I discussed. You have two options. whether you have been continuing a sub array from the past, or you have been starting a new one here. So for that, you make 4 cases and make recursive calls. Last thing, DP. So with DP, what do? If we have the same state being called from multiple places, you calculate it once, keep it, and then if you see the same state again, just return the value from there. So yeah, calculate and keep. I'm keeping here. Wherever I'm returning, I'm storing also, and then returning, right? So storing also and then returning. And if I see that this position ended X, this same state has been seen in the past, then I'll just return whatever the answer was for that state. Seen in the past, how do I check? If the answer is not long max. Okay, base cases. Let's talk about base cases. If you reach the end of the array, and you have used all of your X subarrays, then you return a 0, right? That okay, nothing more as an answer I'll get from the future, so you return 0. But if you reach this nums.size and your X has not been exhausted, that means all your subarrays have not been chosen, then you return long min. This is to avoid the case when, let's say, if all numbers are negative, so you'll ignore everything and move to the end, right, and return 0 from there. Okay, that should not be possible. You have to take at least 1. So that is why, in the absolute worst case, when you take nothing but reach the end, so you return long min, saying that this is not even a possible case, right? Or if you have not exhausted all your subarrays that you wanted to create, then you return long min. Okay, so yeah, that is the idea of our recursion. And yeah, finally, whatever we get as a result, we return it from here. Great. So that is the main idea of this recursion. Actually, this recursion was tougher than, at least for beginners, this would not be the best recursion to start with. So yeah, for this week, what I'm thinking is I'll take up recursion, and that too specifically of the type of cadence, right? Which is the algorithm on which this problem was kind of based. And we'll try to cover that up. So first video probably would be of explanation of basic dynamic programming and the cadence algorithm. Then subsequent videos would be problem on similar ideas. Okay, great then. Yeah, I think it was good interacting with you all. If you have liked the video, just make sure that you hit the like button, subscribe to the channel if you are new here, and let's see you guys in the next videos. Bye bye.